Increase means add. Add the product of 8 and x by 12. What's product tell me to do? Maddie? Multiply. Product is the answer to a multiplication problem. Any other operations you hear happening there? Increase the product of 8 and x by 12. Did we get all the operations? Jagger, what do you think? Do we have all the operations covered? Yes, we do. So now, what's that going to look like then? Go ahead, Jagger.
8 plus x times 12.
Increase the product of 8 and x. So are 8 and x being added together? Oh, I forgot. 17.
Is it 8x plus 12?
8x plus 12. Yes. 8 and x, that's where the product is. So you multiply those together and then you increase that by 12. So you do the multiplication first and then add the 12 on. Letter E, 1/2 as much as 2 less than m. And you hear kind of how I'm reading that? I don't just read it solidly across. Try to listen to where there's a break in what's happening, like this one. Increase the product of 8 and x by 12. So that kind of tells you where your next steps are happening. 1/2 as much as 2 less than m. So what operations do you hear happening here? 14?
Subtraction.
Less than, yep, subtraction. Anything else? 8. Think about if I said, here's 8 candy bars. What's 1/2 as much as 8? Multiplication, yes. You'd be multiplying 1/2 times something. Or we could flip that and divide by what? We can multiply by 1/2 or I can divide by 2. Good. Either one would give me the same result. So now I have my operations covered. 1/2 as much as, that's telling me to multiply by 1/2. 2 less than m. We know that less than is subtraction, so am I doing 2 minus m or m minus 2? 7. M minus 2. It says 2 less than m. So if I put in a number for m, let's say it's 10. If I say 2 less than 10, you're not going to do 2 minus 10, right? You're going to flip it around. So we're going to do m minus 2. And then what? 13. Times 1/2. Is that it? 16? I need parentheses around the m minus 2 to tell me to do that first. If I didn't have those parentheses, then I would do 2 times 1/2 first and then subtract that away from m. So I have to make sure that if there's something I need to do first and it's not already in the right order with PEMDAS, I have to add in some parentheses there. All right, number 2. These two are where we are looking at the given equations and trying to find a pattern. So this is going back to that lesson where we had like 18 times 1 equals 18, 6 times 1 equals 6. And we said the pattern was any number times 1 is itself. So looking at these, what do you see happening here? We have 9 plus 9 equals 2 times 9. 4/5 plus 4/5 equals 2 times 4/5. 3300ths plus 3300ths equals 2 times 3300ths. How could you describe that pattern? 12.
They're adding the same number together to get 2, and then they're multiplying the same number
Times.
times the same number added.
Say that one more time.
They're multiplying the same number together to get 2, and then the same number that they're added, they're multiplying times 2.
You're close. You kind of mixed something up there. 8.
You're doing the numbers numbers plus each other, and then you're timesing by 2 to show that they're both equivalent to each other.
Good. So we can just say that adding any number to itself is equal to that number times 2. Now on this part, as long as you get, it doesn't have to be exactly word for word on the test. Like if I can tell what you meant by your phrasing, then you'll get your credit for it. So don't get too hung up on getting it perfectly worded. As long as I can see that you understand the pattern, then I can give you credit for it. So now that generalizes. Anybody remember what generalizes mean? When it says to the equation that generalizes the pattern, what do I need to do there? Think back to our next step when we did this in our journal. We looked at these, we wrote down what the pattern was, and then we did something else after that. 14?
Do you make your own pattern, or like your own number problem for that description?
We do need to make another equation that follows that pattern, but am I using numbers if it says to generalize it? 13?
Using variables to show that it's
Yes, I'm going to use a variable in there. So how am I going to use a variable to show this pattern happening every time? 12.
x plus x equals 2 times x.
Very good. X plus x equals 2 times x, or 2x. That means that any number you could plug in for x, as long as you put it in all 3 places, it's going to be equal on both sides. Okay, letter B here. Second equation, we have 26 times 18 plus 26 times 103 equals 26 times 18 plus 103. And then 7/8 times 18 plus 7/8 times 103 equals 7/8 times 18 plus 103. And then 300ths times 18 plus 300ths times 103 equals 300ths times 18 plus 103. How could I write a description for this one? 14, give it a try.
So they're using a number, they're multiplying it by 18, and then they're using that same number, multiplying it by 103, and then using that same number, but they're making it like a distributive property, but like the opposite.
Good. Definitely, we see the distributed property happening here, right? It's just that it's on this side. The undistributed is on this side. So if you imagine taking that 26 factor and rainbowing it out over top of those other two, we would end up with this side. So we could say that finding the sum of two numbers and multiplying that by a factor equals let's say is equal to. That makes the sentence make more sense. Is equal to let's say multiplying each number first, then adding them together. So finding the sum of two numbers and then multiplying it by a factor, which is what we're doing on the undistributed side. We're adding these two numbers together and then multiplying it by the factor is going to be equal to multiplying them out separately and then adding them together. Now, how can I make an equation that generalizes? Use some variables in those places. Give you a hint, we need 3 variables in this situation. 3 different letters to represent this problem. Three, what do you think?
X times X plus X.
Well, that means that they all have to be the same number. Is that true?
No.
So we could do X times, and then what can I put in parentheses?
2.
Well, we have to show that it's, how can we show that this works here, this works there, this works there? So X times, but I need to use only variables here. What can I put inside that parentheses? 4?
Y and Z.
What do I do with the Y and the Z?
You
13, what do I do with the Y and the Z?
you add them together.
Good, so we do X times Y plus Z equals, now what's the other side going to look like? So this is the first side where I find the sum of two numbers and then multiply it by a factor. And then what's the other side? Is equal to, how would I show those factors or those variables on the other side then? Two, what do you think? How would I show that I'm distributing that X over to the other numbers inside there? What would the first set of parentheses look like? X times Y, very good. That's my first set of parentheses. I take that X and I distribute it over to the Y. Then I add, and what's the second set of parentheses going to be then? 1? X times Z, very good. So this pattern shows that if I find the sum of two numbers and then multiply it by the factor, that is going to be equal to if I multiply them separately by the factor and them add them together. Okay? All right, turn the page. Now we're on to number 3 here. Mrs. Mrs. M displayed the expression 32 times 6 plus 2 times 9 for the class and calculated that it was 1,746. The answer she displayed was not correct. So, show the steps that you would use to find the correct answer and then identify your answer. So, this means you need to say, like, step 1, what's the first thing you would do out of this problem? Thinking PEMDAS, right? We think about PEMDAS. What would I need to do first in that equation, or that expression of 32 times 6 plus 2 times 9? 14, what would I do first?
You need to put parentheses around 32 times 6 and 2 times 9.
Well, I could, but do I absolutely need them?
No.
Because what goes first in PEMDAS?
Multiplication.
Multiplication, right? We have multiplication, division first. So we have multiplication, addition, multiplication. So we could put parentheses, but it wouldn't change my order, right? I'm still going to do those multiplications first, because if we go off of PEMDAS, there are no parentheses, there are no exponents. So now I'm on multiplication and division. There's no division, so all I look at is my multiplication. So we would say, step 1, what's my first thing I'm going to do then? 8. 32 times 6, which gives me what if I multiply that out? 13? 192. What is step 2 then? What do I do after I multiply 32 times 6? 12? Then I do my other multiplication, 2 times 9, which gives me, everyone, 18. Then step 3, what do I do? 9? I add those together. So I take this total and this total, 192 plus 18. And what do I get when I add 192 plus 18? Yes, 210. So what is my actual answer if I work this out the correct way? 13? 210. So to identify your answer, all you need to do is just give me a circle around it, like to say that's my final answer there. So in this problem, when it says show the steps, this is what you need to do. Break down what you would do first out of the situation, what you do second, what you do third, maybe fourth if there's a bigger expression. Now on letter B, it says to rewrite the expression using parentheses to show how you could evaluate the expression to get her answer. So what could I do to, we know we need 32 times 6 plus 2 times 9, and we need it to equal what she said as her original answer, 1,746. Stop flashing. Okay, so who thinks they could think about where we could put some parentheses to make this answer make sense? $14, what do you think?
The 32 and the 6.
So just around here? Sec-
and then the 2 and the 9.
Will that change my answer?
Yeah, that would be the same.
That would be the same, right? 5, what do you think?
Around the 6 and the 2.
Around the 6 and the 2, so what would that give me? 8. So then 32 times 8 gives me what?
194.
194 times 9. Check that 32 times 8 again, though. 32 times 8. 8 times 2 is 16. Carry the 1. 8 times 3, 24. Plus 1. Or 256. 256, and then if we multiply that by 9, do you think we're going to be hitting close to 1,700? 6 times 9 is, everyone? 54, carry my 5. 9 times 5, plus 5. 9 times 2, plus 5. What? 23. So we get 2,304 if we put the parentheses around that. So that can't be right. What else could we try? 9? So parentheses around this and then brackets like that. Okay, so when we would do we absolutely need parentheses around these? No, it's not going to hurt, right? It's not going to hurt it, but inside this bracket, we only have a multiplication and addition, so we know we'd do that first. So what's 36 times 2? Or sorry, flip that around. 32 times 6. We already did it up here. 192 plus 2. 194 times 9. 194 times 9. 9 times 4. Carry my 3. 9 times 9. Plus 3. Carry my 8. 9 times 1. Plus 8. 17. Did I figure it out? So we don't even really need that parentheses. So really our parentheses need to just go around those 3 numbers. 32 times 6 plus 2, and then take that answer and multiply it by 9. So make sure on the test when you take this, you're not just thinking about only 2 numbers going in those brackets or in the parentheses. You could have 3 numbers, you could have 4 numbers, you could have 2 sets of parentheses. You could have all kinds of combinations. So don't just get stuck on, I need 1 set of parentheses around 2 numbers. Okay? So change it up, trial and error, figure out where that goes. It'll be the same type of problem, but different numbers on the actual test. So you'll have to think it through and trial and error there. All right, number 4. Circle any equations or inequalities. So equations means there's an equal sign in the middle. Inequality is with all those other symbols we've been practicing with. Circle any equations or inequalities that only have one solution. Underline any that have no solutions. So what I would do if this was me taking the test, I would go, okay, I need to circle that only have one solution and underline any that have no solutions. So I know what I'm doing to separate out those 2 responses. Circling any that only have one possible number that goes in there, and underline any that just don't make any sense at all, that you couldn't put any number in and make it true. And then it says, note the variable v cannot be 0 in any of these equations. So none of these you could put a 0 in for that. So we're thinking of all positive numbers basically. All right, so let's look through these. We have 6 equations and inequalities. Who can tell me one they see that either has only one solution or no solutions? Notice if it has more than one possible solution, we're not doing anything to it. 13, give me one.
4, you're gonna circle
On number 4, I'm going to circle it because it only has one possible number that I could put in for letter V to add 22 to and get 76. So I would circle that. 17, what do you see?
it. On number 6, you need to circle it.
Good. There's only one possible number I can put in for V here, multiply it by 2, and get 24. Anything else? Look at those last sets. We have V times 3 equals V divided by 3. Number 2 is the absolute value of V is greater than 0. Number 3, V divided by 3 equals V times 1/3. And number 5, V plus 271 equals 271 plus V. 8, what do you see?
1, the underline.
Correct. Number 1, there is no number that I could put in for V that I could multiply by 3 and divide by 3 and get the same answer. That would never ever work. So now we have these 3 left. Are these 3 ones that only have one solution or no solutions, or are they ones that have more than one solution and we just leave them alone? 13.
Number 5, you have to circle that.
So there's only one possible number that I could put in here to make this correct. What's the number? You can do multiple ones, right? You could put any number there as long as you put the same one on both those V's and it's going to be correct, right? If I put a 1 in those places, if I put a 2 in those places, is that flip-flop commutative property tells us I can flip it and still get the same answer. 4?
Couldn't, for number 1, couldn't you put a 1 for V and it equal 3?
So 1 times 3 would give me
3.
1 divided by 3 would give me
3.
3 divided by 1 would give me 3. 1 divided by 3 would give me 1/3. What about the other two here? Absolute value of V is greater than 0. Is there only one possible answer? No possible answers, or is there way more than one? 12?
There's
Right. We basically put any number in there. 15, put your head down for me, please. Any number, right? Because the absolute value is always going to be a positive number, even if the number inside is a negative. So that means it's always going to be bigger than 0. And what about this one? Number 3, V divided by 3 equals V times 1/3. Is that one possible answer, no possible answers, or lots of different possible answers? 12? Yes, it is. Lots and lots and lots of different possible answers. Just like we said, you can multiply by 1/2 or divide by 2. Remember, if it's a unit fraction, if it has a 1 on the top, you can divide by whatever's on the bottom and you'd have the same response. You'd have the same answer. So if V divided by 3 is the same thing as doing V times 1/3. So we're done there. We have 2 that have one specific answer and 1 that has no possible answers, and that's it. That's all we have to do. All right, number 5, we are looking at, let's see, describe, the inequalities here, this little, didn't see it there. So the inequality is here. Someone read that for me. "17, read that for me. Good. M is greater than or equal to 13. So what are we going to describe in words here? What can M be? What are the possible solutions for M? This is where we would say any number, blah, blah, blah. 14.
Any number greater than or equal to 13.
Very good. Any number greater than or equal to 13. And then how do I graph that on my line here? What's my graph going to look like? 8. Okay, positive 13. So here's 10, 11, 12, 13. Put a circle on it and then close it in. And why am I closing it in, 8? Correct. That symbol is telling me that 13 is a possible answer. So right or left of it? Right. The greater side of the number line is always to the right. And don't forget to shade in that arrow to show that it could go on and on and on and on. And then letter B, we have here. Someone read that inequality for me. 3, read that for me.
Any number.
No, tell me, just read this. Right there.
N is less than 5.
N is less than 5. So now go ahead and tell me what the description should be of that. What can N be?
Any number less than 5.
Any number less than 5. And then how do I graph that? 10? Put a circle on 5. Do I close it or leave it open? Leave it open. Good. Good. And then I would shade. Less means left. So I shade all the way down the left side of the number line and shade in that arrow to show that it could continue on and on and on. All right. I think we'll stop there for today. So go to the front and on, the test is on, let's see, Thursday will be the 11th. Is that right? Yes. So Thursday, 3/11. 3/11.